All right, so let's wrap this up. In summary, the really big idea from this lecture, which we've been building towards with the last lecture, is that we have this estimand. It's what we want to know. We don't know it. We got to use our data to guess what that number is. This is a guess. Okay, so this is not the number that we want. It's just a guess. It's our best guess, but we would also love to know how bad of a guess that is and somehow quantify that. And the way to do it is to compute the standard error of the sampling distribution of this guess. Unfortunately, we can compute what that is analytically, but it involves some population quantities. So it might depend on, for example, the variance of, if here we're estimating like mean age in the population, the standard error of my estimate of mean age could depend on the variance of the age in the population. We don't know the variance of the age in the population, so we have to estimate it using what? The data, right? So we have our estimate as our guess, and then we have our estimated standard error. And these are the things that are usually output by a package in R, for example. You're going to see the estimate and the estimated standard error. But we have to understand what it takes to get there, and what they are, what they really mean. And what are the assumptions under which this estimate actually has an asymptotically normal distribution that's centered at the estimand. What are the assumptions that let us derive what the standard error is, and then how do we estimate it? That's exactly what I'm saying here. The validity of all this is contingent on the assumptions that we're making. So it really is on us to understand what those are, what we're doing there. And then once we have these things, that we can use them to construct confidence intervals or p-values, which are ways to interpret, in some sense, our estimated uncertainty. And typically most R packages that you're using will give you one or the other of these things as well.